default for a long time. So even if I do nothing, you'll basically notice if you look closely that I have these INET6 addresses. Right, so I kind of wondered about these for a long time. 10 years ago when I started getting into this, I was looking at that like, well, what is this FE80 stuff? What is that? So these are the basics. So if we talk a little bit about what I want to try and do is do a little bit of review and try and build on it. So hopefully as we do this, it helps make it stick. So most people know IPv4 really well, so I like to compare and contrast. Right, so if we look at this loopback, right, everybody knows 127.0.0.1, and you can see from direction, right, you can see from this one on top of the loopback, that :1/128, that's my IPv6 loopback. That's this guy on the right. Link local. So one thing, if you're a network guy, maybe a few of you are, there are some things that when you learn IPv6 will actually clarify IPv4, right? Like IPsec, for example, IPsec actually came from IPv6. IPsec was invented in IPv6, and then everybody was like, wow, that's a really good idea, so it got backported. So if you actually learn how extension headers work in IPv6, you'll be like, oh, that's why they did it like that, because from an IPv4, it's kind of like, why did they do it this way? So the same with link local. Link local, I don't think I ever quite understood that 169.254. Like, what do they mean by that? And nobody uses it right in IPv4. But the idea with a link local address is it's supposed to only be significant in a link, or the VLAN. So if I have one plain network that people are on, it should only be significant in that network. It should not be routable. Right? If I have two separate networks, the link local address space is only locally significant. It doesn't mean anything if I go to the other network. And the point of that is, if I have a link local address, if I plug my computer in, even if there's no central authority handing out addresses, if I have a link local address and all of us are on the same network, even without a central authority, if we all have a link local address, we can still talk. We can still do peer-to-peer, right, with nothing else. That's the idea of link local. So I have some basic minimal connectivity. Now it's totally misused in IPv4, but in IPv6 is actually enforced. So this idea of link local is I cannot talk off the link. If you try to do it, it'll actually be blocked. It's forbidden. So, but this is interesting because, for example, in IPv4, if I do DHCP, when I plug my computer in and it has no address, I have to request with nothing. So I rely on broadcast. It's kind of kludgy. With IPv6, I always have a link local address, right? So if I go back here, if I look at this guy, all my interfaces are going to have one of these FE80 addresses. So I can use that on the link to basically say, hey, I want a global address that I can actually get on the internet with. I'm not really going to talk about...
So is that double colon there? What's the significance of the right and left of the double colon?
That's an excellent question. Can I come back to that in a few slides? Okay, that's an excellent question. I'll come back to that. That's basically, it's, let me come back before I go down that path. Private addressing, there isn't exactly private addressing in IPv6, and there's a reason for that. So anybody deal with large networks here? Okay, only a few. So what happens if I have two large networks that are both using private addressing and I merge them together? What happens? Are the addresses unique? No, they never are, ever. So it's very painful. Okay? So the idea with IPv6 is we got to get away from that. We don't want, an unregistered private address that's always going to conflict and makes M&A a nightmare. So the idea with IPv6 on the right is we came up with something called a unique local address. So it's local, but it's unique. You randomly generate it. So that's this big long string. The idea being that if people actually do that, there should be little chance of overlap. So you don't get those painful experiences when you're talking to other people. So probably won't get into that much tonight, but just FYI. Public, we're going to talk about multicast is vastly improved, and there's no more broadcast. So just as a quick reference. All right, so back to the practical stuff. If I want to configure it, there's two ways I can do it from the command line. I can use my old ifconfig tool, or I can use the new IP route tools, the IP. So it's personal preference. The newer IP route tools are actually a little more powerful and a little more flexible, so you can do either way. One thing that will throw you for a loop, now in Linux, notice how it says add. Right, so when I do an IPv4 address, I don't use add. So if I do an IPv4 address for like 80 and then I change it, it replaces it. Because typically in IPv4, I only have a single address per interface. There are exceptions, but typically. In IPv6, that's no longer true. So in anything, any operating system, any device, the expectation is you have multiple addresses. So I just mentioned this because this is like a gotcha. Because somebody will say, they'll type in an IPv6 address and they're pretty long, right? So it's pretty easy to fat finger. Oh, oops, I put it in wrong. So then they'll just up arrow, like fix it and then hit enter. And they think they corrected it. What did they just do? How many addresses did they have? 2, right? If they do it 3 or 4 times, now you have 4. Right, so you actually have to go back and explicitly delete it. Because you can keep adding addresses. Linux by default doesn't limit you until you get to 16. Windows is 100. So that's a little different. Okay, so going back to the double colon and the format. So they're in hex because it's so big, otherwise it'd be insanely long. So that takes some getting used to. 8 groups of 4 digits separated by colons. So it's case insensitive, but according to the latest RFC, you want to use lowercase. Anybody have a guess, especially in this room? Why would I care if it's upper or lowercase? What if I'm doing auditing? If I'm doing auditing, do I care about case? Is that if I have case, then I have to use regular expressions, right? In IPv4, I don't have to worry about case. I have all my scripts that can just parse through the addresses. In IPv6, if I have case, now instead of just using a simple script, I have to use a regular expression, right? So it actually makes it somewhat more complex. So they're trying to simplify it and say, okay, instead of anybody can do whatever they want, there's actually a standard form. And the standard form, it's not like we're trying to constrain people. The idea with the standard form is, that way when I'm doing auditing, when I'm doing scripting, when I'm doing development, there's one canonical form that everybody can agree on, as opposed to everybody does their own thing. So that's the point of that.
Yeah, I'm not sure I really understood that. I mean, because you started saying things about the type of scripting that you use, and I just didn't, maybe I don't know enough about how scripting would be impacted by case sensitivity.
Sure, so it's a good question. So for example, let's say that I run a firewall using IP tables, and I have to give all of the access logs to an auditor. And that auditor is going to review all the access logs that show everybody that's traversing my firewall. So they're going to use some kind of a tool or a script to parse those logs. So the problem is if the addresses, if they don't have a standard form, some are uppercase, some are lowercase, then it makes that person's job a lot harder.
Okay, got
Because
it.
usually auditors don't actually use fancy tools, they just do something like Excel or Excel macros.
Right.
Right, I mean, to be honest,
That's
right?
probably true.
So it makes their job harder. Okay, so in terms of the double colon, because, and I have some addresses, let me skip to the next slide. Because these are so long, we can do what's called compression. So if I have a string of zeros, I can compress that into a double colon. And where that can be nice is, even with this 2001 DB8, I can, instead of having a whole long address, 2001 DB8 00000:1, I can just say 2000 DB8::1. I can compress all those zeros. So for some addresses, it makes it much more readable. And then I give some examples. So I don't want to spend a ton of time on this. I was mainly more throwing this in as reference. But when you actually get into it, this is a good thing to refer back to, and you can find lots of online quizzes. But the idea is just, and it's kind of think like in base 10, right? I can get rid of zeros on the left, but not on the right. Same thing. And then if I can compress the zeros, if there's only one, if there's all zeros between a set of colons, I can compress them. And then the only other thing that's kind of obvious if you think about it is, I can only do that double colon compression once, right? Because if I did it twice, then it's ambiguous. How do I expand it back out? So I can only do it once. All right, so just, again, I'm trying not to spend too much time on the reference stuff, but just so you know, so link local, that's the FE80. It's only valid on that one network, not routable. So that'll always be FE80. And one other small tidbit, it'll actually be FE8, like the whole network part, the first half, it'll be FE80 and all zeros. You actually can't use anything else. Some operating systems won't accept that. So it's actually FE80::/64. So that's one you'll see. The FC00/7, those are EULAs. Those are those private addresses. And you should only see one starting with FD, because FC is reserved. So again, I just throwing it in for reference. And then global. So this is another kind of confusing thing, is that I hear a lot of people say that global addresses are only allocated out of this space. So it's not that we can only use that space, it's just that's all that's necessary for now. Because the space is so huge, we don't need any other ranges. So again, we have one central authority, IANA, that hands out addresses, and so far that's the only pool they've had to allocate. So the bottom line is, when you're creating a global address, it's always going to start with 2. And it's not that it could start with 4 or 5, right, eventually, but we don't need it. It's kind of like with area codes. We don't just arbitrarily use them, right? When an area code gets filled up, then we have another one, right? We add them on demand. It's the same thing with addresses. So right now, that's plenty. So for now, it's always going to be in that range, and that's not going to change anytime soon. And then the last thing, you'll see this in my prezo, is the documentation prefix, 2001 DBA. That's just for convenience. Because we all know that if you put something in a presentation and say don't use it, everybody will use it anyway. So this way you can't use it.
So that's a totally dead topic, right?
Smart thinking.
Okay, so I'm gonna walk through this in terms of, I think this is some of the most practical stuff, for day-to-day stuff, especially if you don't get heavy in the network side. So one thing that's a little hard to get your arms wrapped around is there's no more broadcasts. And I heard somebody make an interesting point. If you think of a VLAN, how do you define a VLAN? It's a broadcast domain, right? So, but that's only true with IPv4. What if there's no broadcast? I guess it's a link local multicast domain. So that is going to take some getting used to, because you don't realize how IPv4 centric our thinking is until you start trying to teach without IPv4. It's a little weird. So that is going to be a bit of a change. But the point of no broadcast is it's pretty common for networks to be multi-protocol. There's older protocols like SNA, or there's even still some people running IPX or DECnet. But there are some other protocols, especially if you get into industrial stuff, like I heard about Ford, right? Any manufacturing company is going to have lots of industrial protocols. So you're always going to have these multi-protocol networks. A broadcast is kind of obnoxious, because a broadcast means I send this traffic out and everybody has to process it. So if I send out an SNA broadcast, even if you don't speak SNA, you still have to process it. So it's just kind of not elegant. So the big reason why they killed broadcast is everything should be protocol specific. So you have groups. That's what multicast is for. That's kind of the logic. I spent a little bit of time on this because I hear a lot of people with IPv6, they'll be like, oh, they're trying to make our life hard. And actually, no, trying to make your life easier. That was the idea. Also, broadcast is a source of a lot of problems. So if you deal with large-scale networks, broadcasts are what take down networks. If you get a broadcast storm, if you have too many nodes, because of the way address resolution works with IPv4, if I have too many nodes in a network, it can actually saturate the network and cause it not to work correctly. These are all broadcast issues. So broadcasting is generally bad news, and so with IPv6 they got rid of it. So instead of a broadcast, now we have the FFO2::1, which is all nodes on the link. And actually, a cool thing about multicast, if you set it up right, is it's routable. So I can change that to FF05:1 and say all nodes in my site, if I set up multicast routing. So this is actually a much more flexible method, because I'll give you an example. A lot of people like to use Wake on LAN. So let's say I'm a systems administrator. I have 1,000 PCs at my company. I want all those PCs to go to sleep to save power. And then I can send out Wake on LAN packets to selectively wake them up. Well, right now I have to do directed broadcasts, which are, there's all kinds of issues with that. Well, with multicast, I could basically send one packet to a multicast address and it goes to all those computers just like that, and there's no security risks, there's no stability or flooding risks. It works great. So this is a really nice solution. It's just gonna take people a little time to get used to it. And just to give some examples, there's actually there's thousands of these addresses, but just a couple. All routers is 2, MDNS. So anybody familiar with MDNS? That's for plug and play. So for example, if I have like something like that camera and it's on a wireless network and I have my computer and they automatically start talking to each other and are aware of each other, that's typically MDNS. You'll notice it's also on Linux and OS 10. Of course, Microsoft has their own proprietary one. But that's the idea. DHCP, same thing. Okay, and then if I look, so a lot of the stuff, and actually this is not just true on Linux, this is true in all operating systems, a lot of the IPv6 stuff, you actually have to use new commands. It's just not in the legacy commands. So you actually have to use the new IP command for this. So if I look at my multicast addresses, by default on my Ethernet interface, I'm going to join the all nodes address, I'm going to join the MDNS address, and this guy we'll talk about in a little bit.
So routers would join the all routers address.
Yep. Yep, and if I'm running a routing protocol, I would join the group for that routing protocol. NTP, there's all kinds of services. Okay, this is another one. So are most people familiar with ARP? Okay, so some. So ARP is how I do address resolution. So if I want to transmit traffic, I need to know the actual hardware address of the system I'm sending to. That's what ARP is for. So this is actually a very major difference, very important for troubleshooting. That's why I put it in here. So if you ever troubleshoot ARP, you're typically going to do ARP-A. There are other ways, but that's the most common. It works in pretty much all operating systems use the same command. IPv6 is different. So if you're feeling bold one day and you really want to see if you understand IPv6, actually turn off IPv4 and see if you can get it working. And that was the first thing I did. If something didn't work, I went to look at my ARP cache and it was empty. I'm like, how can they be talking if the ARP, because it doesn't use ARP anymore. So this is a major gotcha. So you definitely want to remember this. All right, and then I tried, again, I don't want to get too much into the details, but just from a high level, right, if this client on the left needs to talk to this server on the right, he's going to use DNS or something to look up the server's address. To actually send traffic to the server, he needs to know the hardware address of the server. So he's going to figure out, okay, the server's on my network, he's going to use ARP. ARP uses a broadcast, the server replies back, says this is my physical hardware address, the client can send traffic. Now, there's a couple things to know. One, it uses broadcast, right? That's a problem that's gone in IPv6. This is also a very important little subtle thing. ARP does not run over IP. This is a huge change with IPv6. Very subtle, but very important. Okay, if I look at that same story with IPv6, it's similar except we use NDP, Neighbor Discovery Protocol. This actually sits inside of ICMPv6. So quite a bit different, right? So NDP runs on top of ICMPv6, which runs on IPv6. So in other words, my address resolution runs over IP in IPv6. So that's a big change. That has a lot of interesting ramifications from the security side too. Now, one of the problems with IPv4, and this is especially a problem with wireless, is ideally with wireless, I want to have one big flat network. But the problem is, every time one of those clients needs to do one of those address resolutions, it broadcasts it out. So right now, if I look at IPv4, generally the biggest I can get is around 2,000 nodes, because IPv4 is too chatty. If I go bigger than that, the network collapses. It's too much broadcast traffic. So that's actually a major issue with large data centers and with large wireless networks. So with IPv6, the idea is how can we get away from that so we don't have these broadcast issues? And so what they did is they came up with something called a solicited node multicast. So what this is every machine, when you configure its address, it joins a special group. And there's going to be a really small set of systems to listen to that group. So in IPv6, when I want to do this hardware address resolution, only a small number of nodes are going to hear the request. So it's far more scalable. So actually, eventually, in the next 10 years or so, or 10 to 20 years, when we start retiring IPv4, the networks are going to be far more scalable because we won't have nearly as much broadcast traffic. And the way I actually do this, I have. So if I look at this guy, I'm going to take. Well, let me back up for 1 second. So this guy right here, this is my solicited node multicast address, this FFO21. So the first 104 bits are always going to be the same. I take the last 24 bits, that's what I'm showing here. So I take the last 24 bits of my IPv6 address, and this becomes a solicited node multicast address. So it's only the last 24 bits, so there's some overlap, but very little. And what I'm showing here is, once you configure an IPv6 address on an interface, if you look at the multicast address groups that it joins, it's going to join the solicited node multicast address. So that's what that's for. All right. Okay, so a lot of tedious details. Let's get a little more interesting. So this is usually, when I think about setting up IPv6, the first thing I think about doing is, how am I going to get out to the internet, or how am I getting out to my network? So I do that with the router advertisement data. So I was a little surprised by this, but when I set up Ubuntu 12.04, it was not installed. So I actually had to do an apt-get install. I mean, it's pretty easy, but it was not there by default. There's a couple things. One thing I will say, because there's so many different distros, there isn't one central source for Linux that says this is how you do it. So sometimes you have to be a little patient with searching around. Actually, I found some conflicting information until I found the right one, and this varies per operating system. But conceptually, you have to have routing enabled, right? So this service, or daemon, router advertisement daemon, it's a routing daemon. So when it tries to start up, if your node is not configured to be a router, it's going to say you don't have routing on, I'm exiting. So this is how you do it in Ubuntu 12. It varies slightly depending on the operating system, but you should be able to Google it if you use something else. Okay, so pretty typical for Linux or Unix. I basically have a conf file, and I put in some common parameters in here. Okay, so this is per interface. So if you're most likely going to have multiple interfaces, you'll have to have a section for each one. So the advertisement, the first one, that ADV send advert, that's basically saying, I want to send out advertisements. So this isn't exactly new with IPv6. We had this with IPv4, but it was never used. And the idea is, I have a router. When I basically plug that router into my network, that router is going to say to all nodes on the network, hey, you can use this network address. You can send traffic through me. So those are called router advertisements. And they tell the host how to configure themselves. So for anybody who dealt with IPX or DECnet, they had something very similar. So the idea is plug and play. Right? I shouldn't have to set up this super complex thing. I turn on my router, I plug in all my nodes, and it just works. That's the idea with this. So on the, usually there's a lot of times there's a GUI, so you don't even have to get in all the advanced flags. But that's the big one. I try to comment this stuff. So the next two are for DHCP. We'll come back to that in a little bit. I threw in this link MTU. So this is getting a little bit into the weeds. But for anybody who sets up a tunnel to get IPv6, you might need to do this. That's why I threw it in there. Otherwise, you'll have problems. So just file that away if you ever use a tunnel. This is my network prefix. So in other words, when I look at my address, there's two halves. There's the network part and the host part. It's split right down there. So this is telling all the hosts, and I'll come back to this in a second, use this for the network part. And then DNS servers and search lists. So I throw all this on. I basically do my service start, and then if I look at a client on the link, so obviously it's still gonna have the FB80 address, but as soon as I turn that service on, now all the clients on the link, and it doesn't matter if they're OS 10, if they're Windows 8 or Linux, now they're gonna configure themselves with IPv6 global addresses. And they will, if I look in the routing table, they're gonna have that router as their default gateway. So it's more plug and play like. I mean, I can use DHCP, but on a basic level, it's that easy.
So back in your config file, you said 2001, let's see, yeah, prefix 2001:DBA. You're advertising that that's your address, or that's the address that your provider gave you?
Yeah.
And you're handing that down to your clients inside the network?
Yeah, yeah, so there's a lot of options. So this is a simple way. So the simple way would be like a provider gives you a prefix, and then you're going to configure that on your home router, and then it will just work. Actually, where it's going is there's something called prefix delegation. So your provider through DHCP will delegate a set of networks to your equipment, and then that will in turn hand it out to your inside stuff. So there's a whole bunch of different options, but again, in 90 minutes, it's trying to pick and choose what we talk
And
about.
it's a dynamic address? It's not a static IP address then?
Yep.
So then within your network, you've got dynamic and static addresses. And your global address might change if the dynamic address changes, but your static that you use to talk to each other.
Why does it send out dynamic addresses?
Hold on one second. So the idea, here's the idea. I didn't put this in, but this is a good thing to briefly talk about. So with IPv6, the idea is that everything should be as plug and play as possible, and ideally we don't use NAT. Because at the ITF, they hate NAT, right? So the idea is, okay, the average person now is gonna have a pretty complex home network, right? Because if I look at a typical home network, every person might have their own laptop, they might have their own tablet, they might have their own smartphone, their appliances might be online, maybe all their light bulbs are online, maybe the security system's online, right? Even just in a simple home, we're gonna have all these things on the network, right? So that's pretty involved, and maybe I even want to separate those out. Maybe I want my appliances and my kids on separate networks. So knowing that we don't want to use that, and we want all that to be plug and play, how do we make that work? So the idea is we use something called DHCP prefix delegation. So the carrier, like for example Comcast is going to say, okay, I'm going to give a home user a /60. So a /60 in English, it means I'm going to give them 16 networks. So I basically, that's another change. In IPv6, we don't talk about addresses, we talk about networks. All networks are fixed. So the carrier is going to give me 16 networks. So I fire up my home router that I got from Comcast. It basically talks to Comcast. Comcast says, okay, you're going to use these 16 networks internally. And then it turns around and it'll figure, and I mean, they're still working through some of the details, especially if you have multiple networks, but it'll then turn around and it will say, okay, you're network one and you use this prefix, and then it runs DHCP or router advertisements, and it all works automatically. So that's the idea, and they're even trying to, the next big thing is, even if you have multiple carriers, so if I have Comcast and AT&T, they're working on, HomeNet is working on right now, so that'll still all work automatically. I can share the load, that's the idea with IPv6, because for a consumer, right, if I look at my wife, she doesn't want to screw with that. She wants to plug in the equipment, maybe she wants 2 carriers, so if, Comcast chokes because they had a bad day, then I can still watch Netflix through AT&T, right? But it just works. That's where they're trying to get to. And actually, it's coming along fairly well.
But with one provider.
So
every-
does that
Yeah,
make
but every
sense?
node on the network is gonna have multiple addresses. It's gonna have a global address and a link local address and
Maybe more than one
two,
global.
two nodes inside the network could use their link local addresses to talk to each other.
If they're on the same network, yes.
Yeah, and use the global addresses to talk outside the network.
Yep.
Cool.
So what happens if you have a web server inside, and how does like addresses work then for websites?
I mean, if you, a web server, well, you can do reservations. So just like your traditional DHCP,